Example 4, it says example 6 in your sheets because I forgot to change it off traffics before next year. Example 4, graph negative absolute value of x minus 2 is greater than negative 5. Now, what I want to do here is, first of all, this does not already say absolute value of x, so I want to solve for absolute value of x first. So, what I'm going to do is I'm going to move the negative 2 over here, makes plus 2. So I get negative absolute value of x is greater than negative 3. So same rules as typically we do with solving inequalities. We move things around, we change signs. The inequality symbol itself does not change with that type of movement, just moving something and changing a sign as you move it across the inequality symbol. Now, every one of those cases I have says absolute value of x, right? It doesn't have a minus sign in front of it. So I want to make this a positive absolute value of x, so this minus sign has to go away. To change this sign to a positive means I have to change this sign to a positive. And if I change both signs in an inequality, both sides get changed signs, the inequality symbol flips around. And again, that's priority 1 in an absolute value inequality. Get the absolute value expression by itself, absolute value expression, inequality number. It's less than 3, that's a case 2. Case 2, we're going to translate it to negative that number, less than x, less than positive that number. No equals to this time, so open circle at negative 3, open circle positive 3, and we're going to shade in between. Alright, and that's that. Going back to the whole domain thing, in case they do this to us, let's say domain equals a set of integers on this one. Bless you. A little smaller this time. If the domain is a set of integers, notice negative 3 and 3 are both integers, but they're not included in the answer. So when I graph integers, I'm just going to graph negative 2, negative 1, 0, 1, and 2. I don't have to put open circles at negative 3 and 3 because the open circle's purpose is I want to get really, really close to 3 without touching it. I want to include 2.99999 and so on. This is the first integer that's true, that's the last integer that's true. There's no doubt as to the beginning and ending points of an integer graph. So if it is a domain situation like this, that's how you handle it. All right? Open circles do not exist in an integer graph, only closed circles on the true answers.